Hey guys, Mr. Rainey here. Look, today I want to show y'all how to work one of these combination circuits. This one has 7 resistors in it. And I know last week, excuse me, last week we went through and saw how to use equivalent resistances throughout the circuit. So what I want to do today is just demo on how to do one. And at the end of the video, I'm going to put a couple of problems on the board, and that's going to be the work you need to turn in order to get the attendance for yesterday. And I apologize. I had so many things going on with that other class yesterday. Believe it or not, it just skipped my mind when I remember last night that it was Monday night and y'all actually had class. So I won't go through this, and like I said, put a couple of problems up on the board when you get done. So, starting out with this one, okay? Now, the source is located over here in the circuit, and what we do when we find total resistance, and that's the first thing that we have to find in any one of these combination circuits. We're given total voltage, but we've got to solve for total resistance. Now, when we're solving for resistance total, we start furthest away from the source and work our way in toward the source. All right, so the first thing that we come to is this parallel connection of R6 and R7. We need to find the equivalent resistance of that. So being that they're in parallel, I got a 22K and a 12K. Says 22 exponent 3 1 over plus 12 exponent 3 1 over equals 1 over to give you 7.765 kiloohms. Now again, understand what we've done. We have taken this circuit and turned it into into this circuit. So again, moving back in this way, the next thing I see is these 3 series resistors, R4, R5, and the equivalent resistance of 7.765 kiloohms. Okay? So the next thing we have to do is find that equivalent resistance by adding these values up. So that's 7.765 kiloohms plus 3.4 kiloohms plus 5.6 kiloohms equals. And that gives me 16.765 kiloohms. So now, at 17.765 kiloohms is now in parallel with R3. So R3 is in parallel with that equivalent. So I'm going to take that equivalent, since it's in parallel, I'm going to hit 1 over plus the 20K 1 over equals 1 over. And it gives me 9.12 kiloohms. So I've combined this now into one single value. So now my circuit is R2, R2, R1, and the equivalent resistance REQ3, and that's 9.12 kiloohms. So now that 9.12 kiloohms is in series with both R1 and R2. So we just add those values together, 9.12 kiloohms plus the 6.2 kiloohm plus the 5.6 kiloohm, to give you a total resistance of 20.92 kiloohms. So RT is 20.92 kiloohms. I'm gonna store that. Okay, so now we've got the total resistance. Now before I go on any further in the calculations, and remember, we can't add up any currents or can't add up any voltages to find the totals, so we use power. We have to add up our individual powers and check it with our total power. So we're going to solve for power 2. And we solved for RT, and RT was equal to the 20.92 kiloohms. Okay? So, got the 20.92 kiloohms, and we have the total voltage of 15 volts. So the first thing we're going to solve for is total current. So I'm going to take that I'm going to take that 15 and divide it by that 20.92 kiloohms, and I get 717.017 microamps. Okay? So now, I have to sit here and look at the circuit. Well, remember this in solving for these. The number you just wrote down, you're going to use it in one of 3 ways. You're either going to use it in Ohm's law, or you're going to know that something is the same as it, or you're going to subtract it from a total to leave the rest. That's pretty much what you got. So last thing I wrote down was that 717 microamp, and I'm looking around, and I know that total current comes out of the source and goes back into the source. So what that tells me is that it's going to also be the currents through R1 and R2. So, having said that, we got the resistance R2. So IR1 and IR2 both are going to be equal to total current flow, the same as. So now we just wrote this down. I'm going to use these in order to find the voltages across 2. Go ahead and do the Ohm's law. What I just wrote down, I'm going to use to multiply times 6.2 to get the voltage across R1. So that current times 6.2K, that gives me 4.446 volts. So that's 4.446 volts. And then I'm going to take my current and I'm going to multiply it times my 5.6K. And that equals 4.015 volts. So that's 4.015 volts. Okay? Now, I'm going to use these voltages somehow. Now, I can't use it in Ohm's law. It's not the same as anything. So guess what? I'm going to be subtracting them from a total to leave the rest, because if I got 15 volts from here to here, and I'm dropping 4.446 there and dropping 4.015 there, I'm going to leave the rest across R3. So next thing I'm going to do is I'm going to take that, 15 volts and subtract those out. And that gives me a remaining voltage of 6.539 volts across R3. So I just found the voltage for 3. I got the resistance for 3. I'm going to find the current for 3. So that voltage divided by that 20K, that gives me 326.935 microamps. Okay? So now, what do I do at this point? Well, I'm looking at the circuit, okay? I'm going to use this somehow. Remember, I'm going to use that somehow. So, what I'm going to do, I know that I got 717 microamps coming out of here. And I just figured out that 326 of it is going to jump up and go through number 3. So how much is going to be left going that way? That's what I got to remember. So if I look at that, what I'm going to do is I'm going to subtract the 326 microamps from the 717. And that leaves me 390.02 microamps. So that current is going here through R5. Now it splits up, goes through 6 and 7, but it does come back together here. And so I've got that current, the 390 microamps, going through both 4 and 5. So I'm going to take and write that down. And so look what that did. Now it gave me the currents to where I can find the voltages for 4 and 5. So now I'm going to take that current flow, store it up, times the 6.2K. That gives me a voltage of 2.419 volts. Back up. I'm multiplying times the 3.4K. So, get my current back, my 390 microamps times my 3.4K. times 3.4 Okay, it gives me 1.326 volts. Now I'm going to take that current, multiply it times my 5.6K. And that gives me 2.184 volts. Okay, so now, I forget about Ohm's law, everything's done, except now I got 6 and 7. Well, I have to treat 6 and 7 kind of like the way I treated 3. Except I don't have all 15 to subtract these from. What's left is what's across 3. So I'm going to take the voltage of 3 and subtract out the voltage of 4 and 5, and it's going to leave me the voltage for 6 and 7. So I'm going to take that 2.14 plus 1.326. 6.53 ounces. It leaves me 3.029 volts left. Now that voltage, 3.029 volts left, that voltage is going to be felt from this dot to that dot, from those two junction points. So being 6 and 7 are in parallel, it's felt equally across both of them. So that remaining 3.029 volts that I've got is the voltage for both 6 and 7. So I got the now all I have to do is solve for my currents. So I'm going to take and solve that current by taking that voltage and dividing it by the resistances of each one. So that divided by 22K gives me 137.661 microamps. And then divided by 12K, 200.378 microamps. Okay, gives me 252.378 microamps. Now, what I'm going to do next, since I've already worked the problem, I'm going to put the powers up here. But remember, in order to solve for power, all you'll do is multiply the current of each component times the resistance, or the voltage of each component. So voltage times current will give you power. And the total power comes out to be 10.755 milliwatts. So there's your powers. So what I want you to do is go ahead and pause the video. Do this, go through this one, make sure that you can work it and come out with these answers. And then I'm going to put some more on there, and I want you to do those for your homework. Okay? So pause it, and then I'm going to erase it. And I want you to solve for all of it. I want you to solve for the voltages, currents, and power. All right. Okay, there's a couple of them for you to work on. I'm fixing to end it, so make sure you pause it. But look, get these done, take pictures of them, and email them back to me, rthorson@iticollege.edu. Okay? All right, guys, stay safe, stay well. If you need something, give me a call. All righty then. See you later.